Okay, so the second problem that we did on our own, and I'm going to go ahead and work this one out. So if you needed help with this problem, here is a video that can help you with that. So we're dissolving solid calcium fluoride into a solution that already has 0.025 molar sodium fluoride in it. So this is a common ion effect problem because I can see that my solid that I'm dissolving has fluoride, and the solution I'm dissolving it in also has fluoride ions. So we have something called common ion effect that's happening. So I'm going to write my dissolution, which is CaF2 solid dissolving into calcium ions and then to fluoride ions. And then my equilibrium expression is going to be 4.0 times 10 to the negative 11th is equal to the concentration of calcium ion times the concentration of fluoride ion raised to the second power. Okay, so the next thing we'll do is set up our ICE table. So ICE. And so since this one's a solid, the initial, we can just go ahead and X out to the initial change in equilibrium for calcium fluoride since it's a solid. Over here for the calcium ion, the initial is 0, but then we do have an initial concentration of fluoride ion because of the sodium fluoride solution that the calcium fluoride is being dissolved in. Since the sodium fluoride solution molarity is 0.025 molar, and it's a 1-to-1 ratio. For every 1 mole of sodium fluoride, there's 1 mole of fluoride ions. So if you have 0.025 molar sodium fluoride, it is 0.025 molar fluoride ion to start off with. All right, the change plus X plus 2x, the 2, because for every 1 of these, there are 2 fluoride ions. And so the equilibrium concentrations for calcium is going to be X, and the equilibrium concentration for fluoride is going to be the 0.025 plus 2x. Okay. So what we'll do next is solve for X by plugging it into our equilibrium expression. What's kind of nice is that we will ignore the plus 2x again, okay? Just because the change is going to be, that final concentration is going to be so small. So we're going to go ahead and set this up with 4.0 times 10 to the negative 11th is equal to your calcium ion concentration plus, or times, the concentration of the fluoride ion, which is 0.025, and then I'll ignore the plus 2x, and then square that because of the coefficient out in front when you put it into the equilibrium expression. So I'm going to go ahead and keep going with this algebra here. Times 10 to the negative 11th is equal to, now I need to square the 0.025, so you get 6.25 times 10 to the negative 4th times x, divide 6.25 times 10 to the negative 4th to solve for x. And our concentration of, so this would be for the calcium ion, which would be equal to the concentration of the calcium fluoride solution, is going to be x is equal to 6.4 times 10 to the negative 8th molar. Okay, so, and since this is in a 1-to-1 relationship, since it's just the calcium ion, there's only one of those, and that'll be the same molarity for the calcium fluoride as well. Okay, so your answer is 6.4 times 10 to the negative 8th molar calcium fluoride solution when it reaches equilibrium.